Okay, on this one, I am on page 203, and we're talking about lines of symmetry. Now, before I get to the graph, let me show you just some basic examples of symmetry. So I'm going to use my straight. Bear with me 1 second here. I'm going to make a copy of this shape and paste it right here. Okay, actually let me delete that one. I don't want to get you confused with that. Would you agree with me that if this blue line I'm about to draw were a mirror, that we would have a mirror image? The blue line I'm about to draw is a mirror. Do we have the same shape on top and bottom? Exactly the same shape on top and bottom. Well, there's the top. Here's the bottom. And yes, we do have the same shape. So we would say that these two shapes are symmetrical. And that the blue line, the mirror, is the line of symmetry. Okay, let's do another one. Let me draw another one. I'm going to move that one out of your field of vision so you don't focus on that one. So this time I'm going to bring a line and see it's all about the slope. In order to nail this down, I have to get the slope right. Okay, here comes the blue line, and you tell me if it's a line of symmetry or not. Did I make a mirror image on this side to the image on the other side? I did. So yes, this is symmetrical, and the blue line is the line of symmetry. Okay, here's another one. Boy, that's a pitiful looking triangle, isn't it? See, it's all about the slope. If I don't get the slope right, I don't get it right. That was close, but it wasn't straight, so we have to, okay. And then here comes the bottom of the triangle. All right, is the blue line a line of symmetry? Well, let's see. Here's one part. If you hear my tummy growling, I'm sorry. I'm hungry. Okay, and then this part. I'm trying not to eat after a certain hour but I'm not sure that tonight that's going to work. Would you say that the blue line is a line of symmetry and that these pieces of this shape are symmetrical? No, because they're not mirror images. So we would say that this is not symmetrical. Okay, one more. I'll tell you what, let me move these up here, and I'll use this down here for my graph. And I just thought of something I want to show you. We'll do that in just a minute, though. Okay, here's one more. I didn't mean to make that blue. I meant to use black to draw it. Okay, here comes the line, and you tell me if it's a line of symmetry or not symmetry. What do you think? We're going to get a mirror image between this one and the other half? Or are they different sized, different shaped regions? Is that yes for symmetry or no for not symmetrical? It is a yes. This is a line of symmetry. It's also the diameter of a circle. Okay, so now that you've got the gist of symmetry, what symmetry means, let me ask you this. Let's use this one. I'm going to make it larger. Is it still symmetrical? Just because I enlarged it, did I change that? No, it's still symmetrical. Is it still symmetrical? Yes, it is. About the blue line, if I fold it on the blue line, I'm going to have two equal halves. Is it still symmetrical? Yes. It doesn't matter how you rotate it or enlarge it or shrink it. It's still symmetrical because the angles haven't changed. Okay, so I'm going to leave that one upside down just so you're reminded that that doesn't matter. I can rotate it, I can flip it, I can shrink it. That won't change. What matters is where the line of symmetry lies with the angles in the shape. Okay, so with that in mind, let me put in a coordinate plane. I'm still blue. Let's go back to black. It's time for me to stop, guys. I'm getting so tired and I'm making stupid mistakes. Okay, here we go. I'm going to draw a red one this time. And let me bring that lovely parabola right here. So here's a question for you. In this picture, what is the line of symmetry? What's the mirror in this picture? Is it the x-axis? If that is the picture, is it symmetrical here and here? No, that's not symmetrical. What about if I draw the line on the y-axis? Would that be a line of symmetry? Yes, it would, because the y-axis acts as a mirror, dividing that shape in half. So we would say that it is the y-axis, that's the line of symmetry. So we would say that this is symmetrical about or around the y-axis. Okay. What about this one? Is that symmetrical about the y-axis? No, this one is symmetrical about the x-axis because the x-axis would be the mirror. So symmetrical about the x-axis. Okay, here's one more with symmetry. Okay. Is it symmetrical about the y-axis? No, it's not even touching the y-axis. Is it symmetrical about the x-axis? No, it's touching the x-axis, but it's not a mirror image on top and bottom. So where is the line of symmetry? Where would the mirror be in this image? Well, it's going to be right here. So how would we say that in math terms? It is symmetrical because we can draw that mirror image, the two halves. It is symmetrical about the vertical line, that's that blue line that I drew in there, of x equals 2. Because if you go over 2 on the x-axis, you will find that vertical line. So even though that line is not part of the graph per se, whoops, didn't mean to do that. It's not really there, but it is. It's that line on the coordinate plane. So symmetry is something that can be oriented in any direction. Okay, I want to show you a video on rotational symmetry because I really can't draw this. I can't illustrate it with this Apple pencil, so I'm going to post a little video about rotational symmetry. But before I do that, I want to show you this. Let me draw one more coordinate plane. Because sometimes a graph just won't have symmetry. For example, this one. And I'm going to have to freehand it. Well, I thought I was freehanding. Let me try again. I'm just drawing randomly on this graph. It has minimums and maximums, and at no point can I make a mirror image. So if there is no line of symmetry, you just say that. There's no symmetry here. And that's okay. Just depends on the function that you're trying to illustrate. All right, there is one more that I'm going to try to draw, And I'm going to do it in sections. And then I will post a YouTube video about rotational symmetry. So give me just a second here to draw this one. I think I'll make it this color. I'm going to draw that shape. No, that won't work. I'm going to have to show you a YouTube video about a periodic graph too. But let me try to freehand it. If you have an interval that repeats itself, the same exact interval over and over, this happens with sound waves a lot, or earthquake waves. This is called a periodic graph. A regular heart rate, a regular sinus rhythm in a heartbeat is a periodic graph because it repeats the same thing over and over and over and over in both directions. So if you look at the end behavior of this thing, it's going to repeat indefinitely. And that is called a periodic graph. I'll try to find YouTube clips on those two, just to illustrate the periodic graph and then rotational symmetry.